Well, well. Hello. We are now on the third week for the Android development for beginners. Eh, we're starting quite a bit late, but still cover everything on the. Excuse me, I'm still setting up things. Uh, we'll cover everything for the for this masterclass, and hopefully you guys are still around, or well, at least like the presentation. Um, so, in this lesson, we saw a little bit about the permission system. We saw threading. That's really important part. How manage couple threads, a same task, and the handler thread and whatnot. And threading has always been uh, a really important part of programming in general, not just for Android, but modern computers need threading to work because otherwise it will be just sequential, and that way it's not really any good because even if computers can handle thousands of operations per second, you could have two programs open at the same time, and well, that really isn't that good because imagine if you couldn't run like a music player on the background while you're doing a presentation. Well, that's an important part of trading, and we'll I'll talk about a little bit about how how trading works, some ups and downs of the different trades, right? And I hope you find that interesting. So let me begin the presentation. Okay, so trading. As I said, trading, it's really important for, everything, right? We couldn't do anything without trading. Uh, so, for this purpose, we want to cover um, how to do threads in Android, right? All right, so let's begin. This is a little bit of, the outline of what I'll be talking about today. Permissions, threading, a little bit of scheduling, how to set alarm. Well, not how to set them. You guys probably will know how to set them. You follow the course because, of course, all the exercises and whatnot. And I really think working yourself the exercises, it's a lot better than actually seeing a tutorial or anything and just saying, oh, I know how to do it, right? So you really should do the exercises and try to do things on your own. That's the best way to learn to program, right? Um, and then how to solve the exercise this week is a really simple exercise, so you guys shouldn't have any trouble. But anyways, first let's talk about permissions. And what can we say about permission, right? There are normal permissions and there are dangerous permissions. Of course, we'll also see a little bit of differences and why now, if you guys know about older Android devices, they didn't ask for runtime permissions. So we'll talk about that little change, right? So let's start with normal permissions. Normal permissions make use of the phone characteristics, right? Like a vibration, a internet access. You could request how, well, the state of the network, if it's connected to Wi-Fi or not. And also, you can ask when the phone is done booting. There are several applications that you probably have seen that uses this permission. If you have a weather application on your phone, it probably uses this permission, right? Because there's the widget and it has, well, data right there when your phone starts. So a permission, a boot permission, it's, well, the application receives when the phone is finished turning on, and it can do something with that, right? It can start running, or it can send a broadcast or something. Uh, it's a really good permission, but don't overdo it. Well, because if there are too many permission, well, too many applications running this type of permission, then, well, the phone will take a lot of time to boot, right? And that will slow down the phone and it'll be really unresponsive for some time. We don't want to do that, but just so you know that it's there, right? So next, uh, normal permissions, since then they don't require any special permissions, right? They can be used by many applications. They probably are used by many applications. Uh, and the thing is that you don't inform the user when you are requesting a normal permission. You don't have to tell the user the application is going to connect to the internet to download data. You just do it. And now dangerous permissions. Dangerous permissions, uh, you could guess by the name, they are dangerous, but they are dangerous for the user because most of these are actually about the privacy or the integrity of the data on the phone. Permissions like the camera, how to permission to write to the external storage. Those are some permissions that are classified as dangerous. And there are some that are quite obvious, right? Because if you start recording audio without the user permission, that'll be, well, a really big security risk. Um, from Android M, that's a marshmallow, right? It's relatively new. There are a Nougat and Oreo, and Android P is already on its way. So it's not really that new, but from Android M on, these permissions are asked on runtime because, well, there's a typo right there, but before the permission were asked on installation. So when you install an app, like it will show you're installing this app and it has like 10 different permissions and you don't know what they are doing with those permissions, right? Like it has a camera permission, a location permission, and maybe a record audio permission, and you are thinking, what the hell is this app doing? It's um, and since they are not really mentioned on runtime, right? You could sneak a permission right there, and the user wouldn't have not any way of knowing when a permission is really useful for the app and when it's not. That's this this security measure that they took. They asked on runtime so that, like, when you are starting the camera, the user knows, the application is starting the camera because it wants to take imagine it's a QR reader, it wants to scan a QR code. Uh, or maybe it's starting the camera and asking for location because if there are certain applications that if you take a photo of a monument or a really known place, right, like a cathedral or a monument, you could actually track where are you taking that. And well, those two permissions make sense in that context, right? But if you ask for that permission before, there's like no real way to know what the application is doing with that permission. And of course, that led to a big list of permissions, right? Uh, you show every permission you need when it's installing, and then you don't worry about that you have access to every resource. And that's a security risk, right? So that's why it was changed. So the differences and why are they running now? Well, why they are asked on runtime? First and foremost, the main difference between a normal permission and a dangerous permission is privacy and data integrity. Like I said before, right? Um, the privacy of the user, you don't want to, you as a user, you don't want an application to be collecting your data or sending stuff like that you don't know what they're doing, right? And the data integrity is a dangerous permission that allows you to write data on the external storage, right? Uh, when you're using, well, when you're using an application, it writes data to like its own little space. They are in control of this little space that is for only them, right? But when you are allowed to write on the external storage, you could write on anything that you want. So, and writing on external storage also means you can delete stuff on the external storage. So that kind of data integrity is dangerous for an application to have. Of course, most applications may just don't not want to like clutter the internal storage because most phones have very limited space and you can easily expand that using SD cards. Like they go up to 64 gigs or something. Um, well, so that's kind of the main difference. Uh, so now dangerous permissions, as I said, as you know, from Marshmallow on, they require you to show a prompt explaining what they're doing. Of course, this is another thing, another security thing. You know about other phones, right? They don't go asking you permission every single time, but Android does this because it's security, and security is really important for this, for the design of Android applications. And that's why you have to handle those things, because otherwise they won't work on the new ones. Like they'll work on KitKat and Lollipop that are really still quite a big part of the market. They are around 30%. It's a big chunk, right? The other 70% is the newer versions. Uh, so you don't want to leave those out. Security concerns and transparency is the reason for those prompts. You have to inform the user. We want to access the camera to take a photo. We want to access the camera to read a QR code. We want to use the camera to scan the surroundings. I don't know, something like that. Maybe you want to access the location like a delivery app so they can know which store is closest to you, or maybe it wants to know your location to show points of interest, right? Maybe you're a tourist and want to know, uh, well, you want to see everything that a city has to offer. Anyways, this also lets users understand what they are agreeing to. And that's why it's important to be clear, right? Because if an application, imagine you're just running your application and it's only you want to save what you're doing and it shows it wants to write data, you're probably gonna guess, they want to write data to save what I'm doing, right? But maybe they are not wanting to save, but your application actually is running on an autosave, right? And you want to save the things they're doing because they have been working on something for hours and they haven't really saved themselves. Uh, so if a prompt shows that, it just shows a application wants to write on external storage, like suddenly like that, the user will think, oh no, what is this? I don't want to do this. And of course, then you will have to ask again when they actually want to say, right? But if your prompt shows something like you haven't saved in a while, we'd like to save to external storage, the user will think, that's really cool and it functions. And that's why you have to be clear on your permissions. Well, permissions are really important, and you have to understand that from a user point of view. Like from a developer point of view, permissions are just like kind of annoying. You have to request for everything and make a window, a prompt to ask for permission on everything. And then if you don't have the permission, you can't do what you want to do. It's kind of annoying, but from a user's perspective, it's like much better than just like having the application do everything and you're like kind of left in the dark, right? Um, so that covers what I wanted to say about, well, about permissions. So I want to move to threading. Uh, of course, I said before, threading is a big, really big part of modern computers. I couldn't imagine a computer that runs everything on a main thread because it's sequential and then it will get locked. If you have like older computer, right? You know that when you're opening a big program or trying to do a search for a file in your hard drive, your uh, your process will freeze, right? But the rest of the computer, well, most of the time they don't. And the thing is that in Android, while it uses most of Java, right? You have to know which kind of thread you want to use. Uh, the main thread is also known as the UI thread. That's because it handles inputs, it handles displaying the user interface, updating and refreshing all that. And finally, there are some problems uh, that I want to address, right? There are some things in threading that you want to do and something that you should be avoiding. Uh, so now the first thing, the main thread. That's the UI thread. Every single Android process, well, every single Android application has a main thread. Um, um, for simple apps, there is no problem running on the main thread. They'll probably won't do any harm. But apps that handle large data or apps that are like making a playback for a video or something, if you use that, if you use the main thread for that, you're going to get locked. You're going to get a prompt saying your application is not responding. Uh, by default, everything runs on the main thread. This is true for almost every programming language. If you have any experience, well, you should have some experience in Java uh, and some Java threads. You know that when you're doing a Java program, you have you run on a thread. Of course, it's not shown as a thread, but it is a thread. And then you can start extra threads, right? But everything runs on one unless you tell the program to start another thread. And here is why it's important. If you actually don't take care of what you're doing, you will get this prompt. An application not responding prompt. This is a really, really big problem on Android development. Since phones actually don't have the same computing power of actual like desktops or laptops, um, they have, like I have mentioned many times in the last sessions, they have very limited resources. And when you're actually throwing too much on the main thread, the main thread will start skipping frames. That's the times that it's supposed to be updating the UI. Like it runs, imagine once every second, right? Like it can process 10,000 operations a second. And then out of those 10,000, there are like 10 dedicated to updating the UI. If you throw too much on the main thread, it will start skipping those to do the work. And well, that may actually accomplish what you're trying to do. The application will freeze because it's using too much resources, too many resources on your work, and it's not interacting with the user, right? The thread will not have time to receive any inputs or show any output. And if a user sees this message too frequently, he will say this app doesn't work. It gets frozen all the time, and will probably just uninstall. It's a common problem with big applications. Like if it's a very simple application, you probably never run into this problem. But into more complex applications, displaying stuff, maybe you are trying to load an image from the phone. If it's too large, it may get stuck, may get frozen trying to load that thing. It's not actually frozen, but it's not displaying anything. So the phone will show this message saying the application is frozen, it's not responding. As I said, users will probably think this doesn't work, I'm just gonna get another app. Heavy data, downloading data, that should never go into a main thread. Displaying large data, like imagine you have a really huge image, like it's like, I don't know, it's really huge. Or maybe a video, that's a better example. A video like is really high definition. It has like 3 audio tracks and whatnot, and you're trying to load that into the main thread, that's just gonna get overloaded and stop responding. The main thread should stay as free as possible. It shouldn't have to do heavy work, right? And that's because if one of its main purpose is to update the UI and receive inputs. And of course, I already said, if you have the UI thread doing too much, it won't be able to interact with the user. and it will get locked. It's as simple as that. Yeah. So now that we know well, a little bit about the main thread, uh, I'll talk a little bit about an async task. This is what the exercise of this lesson is about, and it's like, well, another thread of execution, right? It's the simplest way of doing an extra thread on Android, because the other ways are like the handle thread and the full thread execution. Uh, let's see, well, whatever. Async tasks are easy to implement. They don't need an UI, and they manually send you like, it's done, you can pick this up. And there's also a problem with this, that it still executes thing serially, right? So you can also block an async task. Like maybe if it's waiting on a result, or it's waiting for something to happen on the application, and you have this async task. It's running and it's doing its own thing, but you reach a condition. Like maybe it has to wait until the user maybe inputs something twice. Then the async task will lock, because it reached a condition where it can't go on, and even if it can do something else with the data it's already using, it won't be able to, because it's waiting on something else. And you have to be careful about that. Async tasks are also for short operations, uh, small downloads and whatnot. Could be a good thing for async tasks, but don't expect an async task to like render a video. Um, it's not a good idea. That's why you have handler threads. There's well, a handler thread is a longer running thread, longer than a sync task. It's good for like operating over long stuff. And one thing you have to be careful. You actually have to handle the outputs of this manually. Uh, but other than that, the main thread, the UI thread, actually uses a handler thread. And well, handler threads aren't without their problems. Handler threads, well, they, how can I say, they persist. Like an activity can create a handler thread and let the thread start running, right? But then the activity is destroyed for whatever reason, and it starts another activity. But the handler thread is still running on the background. It's still going, it's still processing. And then when it wants to return, right, it reached a finished condition and it wants to return the data to the activity. All that activity is gone. So it's not only wasted work, wasted resources, but it will also crash an application if you're not careful. Because it will try to return data to something that is not there anymore. So in that case, the thread is considered like a zombie thread, right? It's there, but it shouldn't be there. And you have to be extra careful. You actually have to destroy the thread yourself. There is no cleanup here, so you have to handle things for yourself. This is why they are kind of more complicated than async tasks, but they are still a great resource. Okay. Now you have seen threads. Threads make our applications run better, and they allow us to engage the user with the UI without stopping our work. But as you notice, there are problems with uh, all the implementations of a thread, and you have to be extra careful when actually using a thread. So, like I said on the handler thread, a thread can actually outlive their color. This means the thread will still stay, still be working while the activity is gone. This could even happen with the whole application. Well, and the other thing is you have to be careful on multi-threading. Multi-threading is a it's a bit complicated, right? Instead of having one thread, you have two threads working on the same thing. And when having two threads working on the same thing, you have to synchronize the threads on your own. You can't expect them to know when they have to synchronize. And if they aren't synchronized, imagine they want to work on the same object, like sending data to an object. Uh, and both of them have to do this, right? And when an object is actually, sorry, uh, well, maybe you're updating the same thing with two threads, and then both threads will actually have to update the same thing, but say the object is expecting two results, right? And a thread will try to update an empty object. If they both do that at the same time, well, one result is going to be missing. And that's the pointless work thing. And the application not responding, it's, well, maybe they will get locked because they are expecting the other thread to finish and they are not going to finish, right? A, a memory leak happens when there is data floating that has no purpose. Um, so, this is how you expect to see a sync task. It's really simple, and this works for simple activities, simple applications, where you're actually, well, not having too big of an application, right? You can do this for the lesson exercise. It will work just fine. But the thing is that this kind of design has a problem. And that problem is that, well, it has a reference to the activity. That means it will keep going, and even if the activity is destroyed and the async doesn't have to do anything anymore because it doesn't have a reference, it will still keep going. And this is the problem with the references, right? And keeping a reference in the thread will keep a reference to the activity, even if the activity is gone, but the thread isn't. So it will keep that like extra data reference in the activity, and that will be just a, well, more space, more wasted data. One thing you can do is declare the async task as static. Making it static will mean that it doesn't keep the reference to activity. So when it finishes, it will like just finish. It won't keep the thread in memory longer than it needs. Now, scheduling. It's there are two main ways. They have their own perks and problems. And well, the first of them is the alarm manager. The alarm manager is it has been on Android since the first time, since the first version, and it's a simple way if you want to run something at a specific time. Of course, the alarm you can think of a clock, an alarm clock. Um, this can run actually down to seconds, milliseconds. From you can give it like run in 3 seconds, and it will run exactly in 3 seconds. But one problem is that it's not very battery friendly. The battery will actually be drained every time. It has to run an alarm. It has to start up the phone, take it off sleep mode, and well, battery is a big concern. So that's why we actually don't want to use alarm manager too often. Of course, if you're actually running uh, um, like a really important thing, maybe you're actually having an alarm that you want to run at exactly 8 a.m. or something. Alarm manager is a good option. Maybe it's like a medical alarm that you can't uh, let the user like take their medications too late or too early. This is still the way to go because the other option, the scheduler, it's the kind of the replacement, right? It was introduced in Lollipop. It runs at approximate times. It's not a guarantee that it will run like if you scale it to 8 a.m. There's no guarantee it will run exactly at 8 a.m. It will run like the next time the system has some jobs that have to run. It may take like 2 minutes or 15 minutes. And there is really no guarantee. But job scheduler actually has lots of perks over the alarm manager, and it can run like if the phone is charging, the phone is on Wi-Fi and not on mobile networks. It has really lots of good functions, and job scheduler actually some of these things that it can do are available as system-wide features in the newest versions, right? But just Keller did it first. And you can actually schedule something and have it run on a separate thread. When it actually has to run, it will run on another thread instead of the main thread. Alarm manager runs on the main thread. And just scheduler, like, if it doesn't have the conditions needed, it will reschedule. And those are really good functions to have on something that is well scheduling stuff and actually has to wait. Lesson reactivity. This one is really simple and it's just about moving some stuff to sync with getting the stuff. The API key is really simple and well, what you have to do is create an async task, right? It's simple. You can just copy the code and like this, like I have said before, you may want to read a little bit about performance on this link right here. Uh, but then you have to update the main screen, right? You update that on post execute, like when you have received the response, it's an object of weather response. That's not actually a model. You can search that in the project, and it will have um, a model object called weather response. From that, you can use the get weather data to get a weather data object, which is another model. If you read the models that are within the project, you shouldn't have any problems. Um, then you get the different items like get weather response, get weather data, get display, name, get display location, humidity, and all that. As you can see, it's a really simple activity. And well, that will be today's lesson. It's a little bit shorter than the other one, but of course you can ask any questions that you want, or if you have something that want to be covered, you can still see on the forums, give us a message or an email, right? So, well, thanks for tuning in, and I hope you guys have a successful week on your projects. And we're almost done. We're on the halfway point, and I hope you guys can finish successfully. Uh, you're really close to getting the certificate, and it's really cool. So, and you can continue on the next course. Okay, guys, thanks for watching, and see you next week.